My name is Hageyemima, and I will be the master of ceremony of today's event. A perfect afternoon, and may we extend a warm welcome to the Honorable, our lecturers, Mr. Insinyur Fauzan S. Azima, STMT, and Mrs. Sevi Novendra Patrialova, SSIMT. The Honorable and amazing speaker, Mr. Christopher C. Gutierrez, PME, RME, and to all the distinguished participants. How are you guys today? We hope you are having a great day. To start the opening of this event, I would like to read the rules of procedure and the agendas for today's event. The rules of procedure as follows. The participant must change their name to your full name _ your institution, turn on the cameras, and use the virtual background if possible. During the presentation, all the participants must turn off their mic, only speak and turn on your mic once you have been recognized or being asked to speak. Last but not least, in order to get the certificate, participants must fill the presence link which will be given at the end of the event. And for the agendas that we all will go through together in this wonderful afternoon as follows. The playback of the department's profile video, the opening, the playback of Indonesian National Anthem song, and will be followed by ITS hymn. Opening speech by Head of Instrumentation Engineering Department, presentation, question and answer session, and closing. And in this closing session, there will be a feedback and presence link. Well, ladies and gentlemen, as we are going to play the Indonesian National Anthem and will be followed by ITS hymn, please kindly turn on your camera and mute your microphone. To the operator, please, thank you.
Departemen Teknik Instrumentasi, Fakultas Vokasi, Institut Teknologi 10 November. Program studi Sarjana Terapan Rekayasa Teknologi Instrumentasi adalah salah satu program studi yang berada di bawah Fakultas Vokasi ITS. Program studi Sarjana Terapan Rekayasa Teknologi Instrumentasi membekali lulusannya dengan kemampuan rekayasa basic science dan teknologi instrumentasi untuk pengukuran, pengendalian, dan pengamanan. Kemampuan melakukan rekayasa basic science dan teknologi instrumentasi ini menjadi penciri atau pembeda kompetensi lulusan dengan prodi sejenis. Mempunyai strategi di bidang pendidikan untuk menjadi pusat unggulan pendidikan vokasi dan riset rekayasa instrumentasi. Fase pemberian basic science, fase peminatan melalui basic engineering, fase pembentukan keterampilan melalui applied engineering. Departemen Teknik Instrumentasi mempunyai sarana dan prasarana untuk menunjang baik kegiatan keilmiahan maupun kegiatan kemahasiswaan minat dan bakat. Smart Classroom berbasis Internet of Things yang dilengkapi dengan proyektor, akses Wi-Fi, dan pendingin ruangan. Laboratorium Instrumentasi Pengendalian, Laboratorium Instrumentasi Pengukuran, Laboratorium Sistem Pengamanan. Sidang untuk menunjang kegiatan sidang tugas akhir dan ruang pertemuan. Fasilitas umum seperti kantin, tempat parkir, tempat belajar, dan masih banyak lagi. Departemen Teknik Instrumentasi memiliki mahasiswa yang berprestasi baik di kancah nasional maupun internasional. Pada tahun 2020, Departemen Teknik Instrumentasi menempati posisi pertama mahasiswa berprestasi terbanyak dari 6 departemen di Fakultas Vokasi ITS. Dengan keilmuan teknik instrumentasi, kita dapat melanjutkan karir di berbagai sektor, mulai dari sektor pertanian, perminyakan, kesehatan, dan masih banyak lagi. Bersama Departemen Teknik Instrumentasi, create the better future.
Thank you, operator, for the display, and thank you to all of the meeting participants for the cooperation. It is now my pleasure to welcome and invite Mr. Insinyur Fauzan Azima, STMT, to deliver an opening speech as a representation of Mr. Toto, the head of Instrumentation Engineering Department, who unfortunately couldn't join us today. For Mr. Insinyur Fauzan Azima, STMT, the time is yours.
Okay, thank you, Sister Yemima, Mbak Yemima. Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum.
Okay, good afternoon, and first of all, let's say our thanks to God because of blessing we can gather in this place in healthy condition. The Honorable to Mr. Christopher as our keynote speaker, and the Honorable to Mrs. Sefi and Mrs. Safira and all of the committee, and of course to all of students of Department Instrumentation Engineer that we already come to this afternoon to listen knowledge from our special speaker. Today, we are very grateful for having the opportunity to attend an international webinar with our special keynote speaker from Philippines, Mr. Christopher Guterres. Okay, first, maybe I want to say hello to Mr. Guterres. Hello, sir. Do you hear my voice?
Yes, sir. I hear it clearly. Hello.
Okay.
Good afternoon. Good afternoon to everyone.
Okay, thank you. And your voice is also clear. So welcome to Indonesia. Welcome to ITS. all of us is instrumentation engineering department. I hope we can share our knowledge each other so that all of the attendants and our students can get a lot of benefits. Okay, today our topic is about plan and equipment risk assessment. That this topic is very related to instrumentation and control, especially about safety. So, in this special occasion, I would like to say many thanks for the committee, Mrs. Safi, Mrs. Safira, and all of the assistants in SIS laboratory for organizing this event, and thank all to the students who have present to take a part in this international webinar. And of course, special thanks I have to say to ETS Global Engagement. I saw the staff academic is here. Okay. And we have to say that this international guest lecture is a commitment from Department of Instrumentation Engineer to provide global insight, global exposure to all of instrumentation engineering students. So this good opportunity, please use to scale up your skill and your communication. Ask everything that you don't know to Mr. Christopher Guterres about plan and equipment risk assessment. Okay, enjoy the seminar, enjoy the game, and so please calm and just enjoy it. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi.
Waalaikumsalam. Thank you, Mr. Insinyur Fauzan Azima STMC for the wonderful speech, and for Mr. Christopher for the talk. And now for the next session will be conducted by our moderator, Mrs. Sevi Novendra Pachialova, SSIMT. Hello, Mrs. Sevi, are you there?
Hello, Hagai. Can you hear me clearly?
Hello.
Hello, Hagai.
Hello.
Can you hear
How
me
are you
clearly?
Oh yeah, you are audible.
Okay.
How are you today?
Fine, thank you. Hagai, how are
Nice.
you?
Yeah, I'm good as well. Are you excited for this event, Mrs.?
Of course. So
That's
excited.
nice. So am I. Are you ready, Mrs. Sevi?
Ready.
Okay, since Mrs. Sevi, our moderator, is ready, then without taking any longer, Mrs. Sevi, the time is yours. Thank you.
Thank you, Hagai, for wonderful opening today. Good afternoon, everyone. To our Honorable Head of Instrumentation Department, our Honorable Speaker, Pak Christopher Guterres, our Honorable ITS Global Engagement, and distinguished participants and our students. Thank you for joining us today. Now I look at this room, we have 200 more participants in this room. Thank you. Thank you for joining us today. Welcome to our today's program named International Guest Lecture Series of Instrumentation Engineering, Chapter Safety Instrumented System, which organized by Safety Instrumented System Laboratory and supported by ITS Global Engagement. First of all, let me introduce myself. I will be serving as moderator in this guest lecture today. I'm Sevi from Safety Instrumented System Laboratory of Instrumentation Engineering Department, ITS. In today's guest lecture, we will have an interesting topic for us to learn together. It is about
plan and equipment risk assessment. And this great topic will be delivered by our honorable guest lecturer from Philippines, Pak Christopher Guterres, PME. Today we already have Pak Chris join with us in this room. Hello, good afternoon, Pak Chris.
Hello, good afternoon.
How are you?
Very fine.
Thank you. Welcome, and thank you for your willingness to share your knowledge, your experience with our student today.
Yes.
Anyway, okay, Pak Chris, if you
Yes.
don't mind, I'd like to call you Pak because Mister in English means Pak in Indonesia, in bahasa Indonesia.
No problem, no problem.
It's okay. Thank you, Pak Chris. Okay, student, please allow me to brief introduce Pak Chris as our guest lecturer today. Let me share. Please wait a minute. Okay. Guys, see my share screen?
Yeah, okay, it's shown.
For the feedback. Wait. Yes, our honorable lecturer. I'm sorry for bad connection. I'm so sorry. I will share it again. Okay. Have you seen slideshow? Okay. Okay. Our Teres PME RME, he's a college instructor in Sur Polytechnic College, Philippines. Please correct me if I'm wrong saying the pronunciation. I'm so sorry. He's also a fire safety practitioner, professional mechanical engineering, register mechanical engineering, register master electrical and pollution control officer. Mr. Pak Christopher have finished his education in Bachelor Science in Mechanical Engineering at the University of Nueva Cáceres, Naga City, Philippines. He have been before now he have been so many work experience in this table. I just take some of this because so many experience he has. The latest experience is as a technical assistant manager, engineering assistant manager, quality and environmental management representatives, safety officer, pollution control officer, and production supervisor in Philippines. He have been also in Malaysia as process engineer. Wow, it's so the real practitioner and industry and instructor polytechnic. Yeah. Okay. That's all about the short brief profile of Pak Christopher. Before we start the lecture, for the participant, for student, please allow me to remind you about the rules. Who participant don't have any problem with your internet connection or issues in your device, please turn on your camera so we can meet and see your face, even though virtually. And please turn on the microphone during the lecture. And Pak Chris, the duration will be 70 minutes for delivery the lecture, and followed by 30 minutes for Q&A session. All
Understood.
participants are allowed to ask to Pak Chris by typing in chat box or directly speak to Pak Chris. Please don't hesitate, student, to ask directly verbal, because our team will help you to translate if you need any help. So don't hesitate. Don't worry about that. We will help you. Okay. Anyway, Pak Chris, this is the first time guest lecture with native speaker for us. So I hope you don't mind to speak slowly so our student can get the message perfectly. Okay. Without any further ado, Pak Chris, we are glad to please you to start your lecture. All time is your Pak Chris.
Okay, thank you very much, Mrs. Sethi. And I would like to say good afternoon again, everyone. Actually, I am expecting that the Indonesian will look like a Filipino, and I am right. You are more handsome, more beautiful than the Filipinos. Actually, then I don't know if you are much friendlier. I think so. We'll find out later. I was supposed to come in Indonesia last 2019 when one of our company is transferring machine from Indonesia to Philippines, but because of COVID-19, I was hold. It was hold. But anyway, let me remind pala that my internet also has having problem because the fiber optic in our province have some damage because of 3G. So I'm hoping that you would understand that I cannot open also my camera, and I don't know if I can open my presentation. So I will open now. Please tell me if you can see my presentation. Can you see it now?
Yes, Pak Chris.
Okay, let me put it on the slideshow. Okay. So again, welcome to this webinar. And let me introduce myself again. I am Christopher Gutierrez, and I personally extend my warm greetings to everyone who's joining today for the discussion with the title Plant and Equipment Risk Assessment. So the topic that I am going to discuss are the following. First, we will going to start the introduction to the topic so you can have some background regarding occupational health and safety. We will discuss here the existing condition of occupational safety from the different report of concerned agency, such as International Labor Organization. We'll use the data. And we will also discuss the advancement of instrumentation in terms of plant and equipment and the effect of this advancement and instrumentation. We will also discuss the safety instrumentation system, or SIS, as a mitigation controlled measure. Also included is I will give some on-the-job accident that actually happened here in some of the plant from my previous company, and show some corrective action so that it will be served as an example. You will understand what can the instrumentation can do in the production, in the manufacturing. Also, we will going to discuss the hazard identification, risk assessment, and control. Under this, we will going to apply some suggestion guidelines from International Labor Organization and other standard giving bodies. We will also discuss how to prepare the hierarchy identification risk assessment, how to evaluate, identify the risk, and how to control using a hierarchy of control measure. At the last part of our discussion, we will going to have a summary in the form of conclusion and endnotes. These are the topic that we're going to discuss here in the webinar. Before I move on, I would like again to ask if I am speaking very fast. Could you confirm?
It's okay.
It's
I think
okay. Okay. So, okay. Before I move on with the discussion, the formal discussion, I would like to read this declaration from International Labour Organization. It says, safety and health working condition is a fundamental to decent work. This is a declaration from Centenary Declaration for the Future Work. It was released 2019. You can see this one of Chapter 2, Section D. Now, why did I highlight this one? Because I'm also wondering, as a practitioner, if this declaration we can achieve. Okay, because based on this report, same agency as the ILO or the International Labour Organization, they estimated that around 2.3 million workers around the world is affected by work-related accident or disease. And this results to around 6,000 deaths every year, or single day. And around 340 million occupational accidents every year. So this is the extent of the occupational accident worldwide. Now, as a case study, I would like also to show you the data taken from the Philippines. But this one is a little bit late because I don't have the data, the latest data. Maybe they are not yet released. So in the Philippines, this one is reported by Philippine Statistical Authority. So you can see on the first graph, the accident actually going down by around 5.7% from 2013 to 2015. Then actually this one is very late, but I don't have any other data. So, but what is important here, significant here is the injury, the result or the extent of that accident is going up by around 3.8%. A contrasting result. Now, on the second graph, you can see that 3 out of 10 occupational injuries with work stoppage or with the operator or the employee cannot work is actually coming from plant and machine operator in assembly, or in short, in the manufacturing. Now, also significant finding here is that the highest actually is in the construction, or this one is manual laborer. But you can see on the following survey, it go down direct, very low. In comparison to the manufacturing, it's actually going up. Okay, now on the third graph, we can see that the injury resulted 97% with a temporary injury. 2% actually resulted in permanent injury, and 1% resulted death. One more, I think, need attention. Significant findings is across the industry, manufacturing accounted for 50% of occupational injury. So this is very significant. Okay, what is the difference between the charts number 2 and this one? This highlighted, this 50% actually included both the major the injury that caused downtime and the minor injury. So, but anyway, the highlight this one is the 50% injury that was incurred by the manufacturing. Now, we will going to check what is the difference or what is the the changes or the development? Why is it that the manufacturing is the highest? Now, if you look at inside the manufacturing or the industry, you can see the biggest change actually is on the advancement of instrumentation. Okay, many countries, even in your country, I believe in Indonesia also, advancement of instrumentation or the automation is very significant, more significant than the Philippines, I believe. Because there are so many benefits of automation, such as the reduction of total operating cost, increase of production, improve operator efficiency, productivity, increase in safety. Let me highlight this one, increase in safety. Then the maintenance, precise measurement, improved monitoring, and many other. This is why instrumentation is very, very important. Now, let me go back to the increase in safety. I always thought that this increase in safety is the result or the cost why the incident in the first graph actually going down. But what cannot explain by this one is the result or the extent of injury that is going up. Now, why do you think is the extent of injury is going up? Even though the accident, the happening of accident is going down. Now, the primary reason, in my opinion, is that the increase in automation makes the process more complex. And because it becomes more complex, there are many things to monitor, such as many parameters, such as the temperature, pressure, position. And one of these, if this one failed, may result to injury. It may not be the person operating the machine, maybe others. Okay, so that's why mostly of the operators of machine are trained personnel. Now, let me show you some actual accident happened in the manufacturing. So this one happened actually in my previous company, this one in the Philippines. So what happened here is that the hand of the operator caught by this press machine. This one is still lucky. Why? Because all of the finger was not cut, only broken bones, but still can heal. That's why it's very lucky. This one is a very strong machine. Now, what's the problem with this machine? This sensor, let me highlight this one. This one is a curtain sensor or area sensor, I mean. The problem is with this one is it fails, it malfunctions. So that's why instead, when the hand actually crosses this one, supposed to be the machine stop, but unfortunately it was delayed, so the hand was caught. This problem also happened in Thailand, one of the branches of my previous company. So also the same machine, the same sensor. Okay, the sensor also again failed. So what's happened to the sensor? Now, if we study the sensor, this is an area sensor. This one is the emitter. This one is the receiver. Now, this emitter produces light and received by this receiver. So when the hand or any object crosses this one and cut the light, this particular relay will going to open and stop the motor or the machine so that nobody can hurt. But the problem is this particular relay is the one that has malfunction. It's intermittent problem. It's not actually damaged, but sometimes it's okay, sometimes it's not okay. So intermittent. That's why it's very, very hard to solve. Now, the question is there a solution to this one? Of course there is. Everything has a solution. So now, what is the solution? Put the self-check circuit. Okay, so Previously, this is the circuit, initial circuit that has failing. Now, what we do is we install additional circuit that is very independent in order. The function is to check this particular relay if okay or not. If this circuit detected this relay have problem, then the circuit will shut off this motor, including this one, this circuit. So the machine surely will stop. Now, this kind of self-check, you can find it in the many sensor, current sensor, auto sensor with level, or I mean type 2, and protection level C, category C. Omron has it, those sensor with series number F3. They have already safe check. Now, there's another system that uses this concept, and this is called safety instrumented system, or SIS. Then what is SIS? Okay, SIS is a safety instrumented system that control the system and operate if a certain safety incident occur. So that is the meaning of safety instrumented system. The function of this SIS is to monitor the process for potential dangerous condition and take the action when needed to protect the process. Okay, let's take a look at, to understand this one, let's take a look at this picture, or this figure, the drawing in our presentation. Assuming that this is the machine, the movement of this machine are being controlled by this controller. Okay, the movement is based on the design to create whatever product it is designed. Now, it also has installed many safety parts or safety.
Hello, Mr. Chris. We can.
Yes.
Yes.
Okay, I'm sorry. I thought you cannot hear me.
Yes.
Okay. Now let's continue. Now, assuming that this particular machine is suddenly have a problem, or the sensor doesn't have a problem, this particular control system will act independently. Whatever happened to this one, this particular control system will not be affected because this one is isolated. Okay? So this particular system is what we call safety instrumented system. Now, to explain more of this, we will have some very simple example. Assuming this is your process, and this process actually is to maintain the level of the liquid in this tank. Okay. In order to maintain the level of fluid in this tank, we will have some sensor here to report or to monitor the level, the actual level of fluid here. Then this sensor will signal, maybe in the form of analog or digital, to the controller, so that the controller will compare the data and send the output signal to this connection, controlling the final element, which is the valve, so that it will only produce or input a certain amount of fluid that will maintain this one. So that is your process. Now the question is, what if the particular sensor fail? What will happen? There are two ways. Either this one go down or this one go up. Now you select which one is more dangerous, the empty one or the full one. Okay, if I'm going to select the full one because it may create a pressure here and possibly this one will crack. Okay, in order to protect that incident of blowing up this tank, we will need an extra or different isolated system that will detect and protect this tank independently. Okay, and now this is what we call ISI. This is a totally isolated or independent control system. What happened in this is that if ever the sensor failed and this fluid go up, immediately this particular sensor will detect and put a signal here that will be compared by this controller so that this particular valve will shut off the flow and return back to the normal position. That simple control system. That's how the ISI work. Now, there are three parts to make a complete circuit or complete system for ISI. Number one is the sensor, which is one to detect the data, and also the controller to process the data, and the final element, which is the actuator. Now, let me give you some example or some project that we have done in a company that uses this ISI. Okay, actually this is also an accident happened in India. Same company, but the branch actually is India. What happened to this machine is that this particular machine has three mold. 1, 2, 3. Now, in India, the accident happened, all of this mold fall down. Okay, that was a major accident. Imagine you are pressed with this metal, very heavy one, then this particular mold is very hot, around 200 degrees. Imagine the fate of that operator caught on this machine. Now, the Indian factory actually created a system, also SIS, which is this one, an independent system that protects the operator. If ever the problem occur, this one will hold. Okay? This is a pneumatic. This machine actually is a hydraulic machine, but they also created a pneumatic so that the system, this particular machine will not corrupt the safety system that they installed. This same concept also we have done in the Philippines, but different concept. I mean, different mechanical or the design different. So what we do, assuming I will give you some animation, assuming this is the machine. At initial, the door is open, and what we have installed here is that, okay, I'm sorry, I cannot see my, okay. Okay, what we have installed here is this one, a support lock bar, 4 sets, and also this lock for the door. Now, what happened here is that, okay, sorry. What happened is that if the machine is not running, not yet operating, this door you can open or close, and the initial position of this lock bar, safety bar, is actually retract, okay, in the out. So you can load. Now, please be very observant on this mold, because right now, even the door is open, this safety bar is still retract. Why? Because there is no mold up, nothing to pull. That is why the initial position. But once the machine is already loaded and you start the press machine, the press button, you start already operating, what will happen is that when the machine will close the door, lock. Then you cannot open the door until the process is finished. Okay? Now, also, since this is in the process, this particular lock bar or the safety bar is actually retract position. Now, once the mold is going up, okay, already the first one is going up, this two is still no load, nothing inside. This one will be load later. This one will go down. So this, therefore, if the mold go down, what will happen is that the door will open, then the safety bar will go in. The purpose of this one is whenever this one fall down, this particular safety bar will hold the mold up so that it will not fall on the hands, because we will load the material here. It will not fall on the hand of the operator. That is the purpose of that one. Therefore, can load conveniently and safely. Now, the next one is you close again. If you close this one and operating again, this one will lock. You cannot anymore open the door until finish the second layer. Then the next layer will open. Then you load again. Then after you load, you close again. You see, retract again the safety bar, and the door is closed. So that is the process that we have done on this particular problem. I hope you understand the mechanics or the procedure of how the sensor is being conducted or moving. Okay? Now, for now, let's pause for a while. Okay, by the way, this is my team. This is when I was working in the company. This is me in the white uniform. So this is my team of technical personnel. We have brainstorming on how we solve every problem that we have encountered. Now, for this moment, I want you to also to pause a little bit, okay? And also have some brainstorming. Because I don't know if you notice that mostly of the problem that I have presented, the cost of the problem or the initial cost of the problem is the failure of the sensor or some part of the system of the machine. Now, the question is it really the sensor or the part of the machine is the main cause? Okay? So that's why I want you to pause a little bit, maybe 1 minute, and think about the main cause. I give you 1 minute to think about this one. And I will leave you this question. What is the main cause of the accident? Okay? So I hope that you can, don't worry about it's not a graded recitation. I just want to have some idea from you. Okay, you can put your answer on the chat box. Then I will give you time of 1 minute and we'll start now. I want to see your answer. If the cause is the sensor, you said yes, and we will find out. If no, can you suggest what do you think is the main cause of the problem or the accident? Okay, you can start now. Oh, okay. I think I have Okay. So many answer actually human failure, violation of rules, human error, human failure, system failure, HMI bad design. Okay, thank you very much for your suggested cause of the accident. Okay, so let's continue. I will not going to answer verses 1. What we will going to do is have some process of assessment to know the cause of the accident. Okay. Mostly of the Japanese, actually I admire a Japanese company because of they have many ways of solving problem. Okay, they have many methods. And one of the method that is very simple that I am going to use is that they called YY analysis. This is the simplest method of finding the cost. Okay, it's easy. The procedure is just ask why. Minimum is 5 times because the 6 ones is very hard. Okay, maybe you cannot answer. We cannot answer anymore. So what we're going to do to check if your suggested cause of the problem of the accident is actually the human error, the system fault. Okay, we will check. Now, let's start now. We will ask first why. The first why is why the accident did happen. Because the sensor did not function. Second why the sensor did not function. Because the relay of the sensor was damaged. You will notice that the second one actually is the one we have given a solution already using SIS, right? Now, but the question remains is that what is the main cause? Okay, we will ask again another. If we can answer the why, then there is another cause underlying, much deeper than that. Let's again another ask why. Why relay of the sensor was damaged? Because there's no regular maintenance on the relay, particularly on the sensor. Let's ask again another why. Why number 4? Why there is no regular maintenance of relay? Because regular maintenance of relay was not considered. We did not consider at all. We just use it. Now, the 5 why is that why it was not considered? Because there was no systematic risk assessment to determine the possible safety failure that may occur to the machine. We did not include that particular portion of the machine on the systematic risk assessment. That is why we do not know when it is going to fail. Now, how do we know if it is the right cause of the problem? What we are doing is that if this Y1 can answer by this cause, by this reason, then it is the most probable is the cause of the accident. How are we going to do that one? We replace the because by since and the why by therefore. And let's see if we can answer the first why by this pip number reason. Okay, let's try. Since no systematic risk assessment to determine the possible safety failure that may occur to the machine, therefore, the regular maintenance was not considered. Since the regular maintenance of the relay was not considered, therefore, there is no regular maintenance in the relay. Since there was no regular maintenance on the relay, therefore, the relay of the sensor was damaged. Since the relay of the sensor was damaged, the sensor did not function. Since the sensor did not function, therefore the accident happened. You see, a simple why method can answer and can find much deeper cause of the accident or any problem in the manufacturing. Simple as that. Now, do you think the rest, there's no risk assessment or there's no systematic risk assessment can really cause such problem? To me, as a 20 years working in manufacturing, yes, it is. It's not actually the sensor. There is a way how to protect the fault of the sensor. If, only if, you can consider it. Okay? So, let's use this one. So now, what we have find out is that the failure to identify the hazard and assess associated risk is the main cause of the accident. Why? Because in the first place, the accident should be preventive if we have already considered it at the start. Okay? Now, let's understand what is risk assessment. Let's define what is risk assessment. Okay. Risk assessment is a process of evaluating the risk arising from a hazard, taken into account the adequacy of existing control in deciding whether or not the risk is acceptable. In other words, a risk assessment is thorough observation of the workplace, identifying things, situation, process, materials, and others that may cause harm, particularly people. So that is the meaning of risk assessment. And risk assessment describes overall process of or method on how you be able to analyze the risk. What method is it? It is, number one is to identify the hazard and risk factor. Number two is to analyze and evaluate the risk associated with the hazard. And the other one is to determine appropriate ways to eliminate the hazard. Actually, by this particular method, you can already determine by just looking at it. It is a method, it's a systematic method that can prevent accident by following this systematically. Okay, now what is the importance of risk assessment? Okay, the importance of risk assessment, what is the importance of risk assessment? Risk assessment will help you, number one, create awareness of hazard and risk. That's the number one. Why is it important? Because if the person or the operator knows the hazard associated of the things they are doing or the machine that they are working with, they themselves can already avoid such risk, right? Another one is to identify who may be at risk, okay? If we are working with the machine, then the operator is at risk. Why is it important to know who is at risk? It's because you can put already some precautionary measure to protect that person or that operator. Another important of risk assessment is to determine whether a control program is required or for a particular hazard. Okay. We need to know the hazard associated with such a process is because we can put a program or a system that can control such hazard. Okay, so another important help of the risk assessment is that it determines the control measures are adequate or if more should be done. Okay, assuming you have a machine, you have a emergency stop. Now the question is the emergency stop enough? What if the machine is moving very fast? Is the emergency stop is enough? Maybe not. So risk assessment will help you assess if the existing precautionary measure is enough or we need to put additional more. Another help is to prevent injuries or illnesses. Another help is to prioritize hazard, because in the risk assessment, you can prioritize which one is the high, medium, or low risk. So you can prioritize the highest. So that's why risk assessment is very important. One more important thing is that it can help you meet legal requirements. Because when you know the hazard and you put particular controlled measure, then it is easily can comply to legal requirements. Remember that the plant and equipment risk assessment is one of the key tools for improving occupational health and safety condition of works. Okay? And in order for us to have a wider or broader assessment of risk assessment, we need to consider the process, not only the machine, the plant, the tools, but also all the processes, normal processes. More importantly, all the process that is not normal. When I say not normal, it means the process is not connected to the production, or the process is only done when it is necessary, such as the installation of the machine, maybe maintenance, repair, breakdown, and servicing. That is a not normal operation. Remember that the law is not just for the building, it is also for the machine or any other facility that is in your manufacturing area. In addition, if we want to have a high level of safety in our plant, in our equipment, we need to have a layer of protection. Even though we have the safety instrumentation system, we will need to have a certain layer of protection so that we can assure that the accident will be prevented. Looking at the picture, we can see that assuming the green one is the process, the first layer of automation is the process design. The second layer usually is the critical alarm. This one is when the parameters is out of control or have deviation. This one will alarm, and you can manually reset this one. The next layer is the automatic system, the safety instrumented system. Okay. The next layer is other devices, other technology. If this one is a tank, you can put a relief valve. Okay. The next layer is the plant emergency. If you cannot contain with all those precautionary measures, you still cannot contain, then therefore plant emergency response. If still very big, maybe very big accident, then community emergency response. So these are the standard layer of protection. Now, if you're going to check this one, to look closely on this one, actually you can divide this one into two major types. This particular layer is what we call mitigation layer, and this one is the preventive layer. Okay. Oftentimes, we must prepare for these two in order to have a higher layer of protection. Now, there are many models or there are many guidelines of how are we going to conduct a risk assessment. This one, this particular steps is actually from International Labor Organization. It has a 5-step, but there are many you can use. I will show you later. So Based on the International Labor Organization, step 1 is to identify the hazard. Number 2 is to identify who might be harmed. And number 3 is to evaluate the risk. 4 and 5 is actually documentation. Okay, record who is responsible. Number 5 is record the findings. So this is the suggested guidelines for risk assessment that by International Labor Organization. Other standard, you can find it actually online. This one is a occupational health, safety and health. This standard is from European Union, so they are using this one. Another one is the occupational health and safety. This one is released also by International Labor Organization, but is using by Australia, a Canadian, and also the Philippines have also occupational safety standard. You can find it on this email. One more standard we can use is the ISO 18001 certification. This will help you assess and have a higher protection in your plant and machines. Now, in order for us to have a better understanding of how we manage the risk, this one is a flow chart. Okay, so in order for us to manage the risk, the same, we have first we have to identify the hazard and identify the risk. This is part of the risk analysis. The next step is to assess the risk. Here we have the process of evaluation, ranking. Then we know which one is acceptable, no need to act, and what hazard is high or very high. So we need to put a countermeasure. Okay, after we do the countermeasure, we can now test it to the line and find out if it is okay or not. If not, go back again, check, then plan again. After this particular flow is derived from dimming cycle or plan, do, check, act. Okay, now since we have already discussed the risk assessment and some important matter of this, the question now is, how are we going to start the risk assessment? How are we going to prepare? Again, from International Labor Organization said, of course, the very first thing that we have to do is to form a team. The team may be composed of the safety officer, the health and safety representative, and of course, those that are affected by the hazard, that is the operators and all those personnel in the production. So you have to form, and those persons should be a member or a leader. Okay. According to the International Labor Organization, in order to prepare the HIRAC or the hazard identification risk assessment, the first thing to do is to identify who are the exposed workers and must give a particular importance of this worker, especially workers with special needs, such as pregnant women, young workers, and aging population. Okay. Also, those with person with disability. You have to look at it. Another activity that you have to do is to check also those personnel or the process with doing the abnormal processes, such as the maintenance, cleaner, contractor, and visitor. You have to consider that one also. The next step is also you have to consider or familiarize the characteristic of the task, the work equipment, the material in the procedure. The purpose of that one is to easily identify the safety measure, the current safety measure in use. Okay. Also, to identify the work accident present, including the occupational disease present, if there is, related with the workplace, to aid the analysis. The next one is to identify legislation. Is there a law governing such process, equipment, machine, or is there a company regulation related to that machine, to that place, to that equipment? So those are the things that you need to consider. And additional activity that you have to do and also consider to help you identify all the risks, all the hazard, and identify the risk is to direct observation while doing work. Okay. Another one is to interview the workers and managers, check work accident occupational disease record. All the record you can check to identify more of the problem. Check equipment, machine technical data, especially the maintenance record. Examine the material data sheet, consider legislation. So those are the things that you need to look at to identify the hazard and the risk associated with that hazard. Okay. After we have identified the risk at the hazard and consider or assess the risk, we are now ready to conduct risk evaluation. So what risk evaluation? What is the meaning of risk evaluation? Risk evaluation is the process of determining whether the identified hazard is low or high or unsafe. That is the simple definition of risk evaluation. And there are two ways to do it, the quantitative or the qualitative. Okay. Quantitative uses calculation. Okay. It also involves two components, such as the probability that risk will occur and the severity of the potential consequences of that particular hazard. The qualitative, meanwhile, is the simplest one. This one is the one that is often used in many factories. Even here in the Philippines, mostly that I see is that they're using is the qualitative one. Okay. Because the qualitative one is more easily method. All you need to do is to estimate the likelihood that the hazard will occur and the potential severity of the harm. And combining the two, now you can now evaluate what is the hazard, what the level of hazard of that particular, what level of category, what likelihood, or what is the score, or what is the severity of that particular hazard. Now, let's take a sample. This one, I take this one from British Standard. Actually, this one is also using in my previous company. What you need to do is make a descriptor. Okay, then assume that all those that it will fail or have hazard over 5 years, we can say that it is rare. Incident possible or within 2 to 5 years, maybe we can say it is unlikely. Incident happen in 1 to 2 years, slight or moderate. Incident could occur sometimes 1 month to 1 year, maybe we say likely. Incident will occur undetermined because maybe it happens 0 to 1 month or 1 day, 1 month, then we say almost certain that it will occur. Then we check the consequences of that hazard. Okay, so we make also a matrix of that one. Assuming, let's say, if that particular hazard will not produce a very big injury or will not have a serious injury, we can say almost negligible. Or this particular hazard will not produce a work stoppage, then maybe we said the category we assign as negligible. If the hazard is likely to affect employee in the next day or maybe 1 day, then we say minor. If it's need a medical treatment, then we say moderate. If injured and require hospitalization, then we say major. And if this one is a permanent incapacity or death, we say severe. So based on this matrix, we can now calculate what is the final severity of that particular hazard. Now, on the right side, it is the risk score calculator. Assuming that you have the likelihood of the hazard is slight, and the category of the hazard you have checked is major. Now, on the calculator, all you need to do is to trace this one. On the hazard, you say major, or the consequence is major, and the likelihood is, say, unlikely, we put, then that hazard belongs to the medium category. So that's how we're going to evaluate the risk. Okay. Now, you can use this particular table to rank or to evaluate all the hazard that you have found in the plant and also in your machine. You check it one by one and score it. Now, after you have evaluated all those hazards you identify, we can now ready to rank it or classify it. Now, how do we do the ranking? Based on the risk evaluated, obtained during the risk evaluation, we need to sort it. Now, it is very important that the sorting is not just the classification. Actually, is you can do it by within the company, but the action or the judgment, if acceptable or not, should be dependent on the legislation or any law that is approved in your country. Okay, if there's no law about that acceptability, then you can repair that one on any eligible or standard, international standard or occupational safety and health guidelines. Okay, so it is better, or it is mandated that to score the acceptability or not is not something that you can decide quickly. It should be within the standard of that law, of the known guidelines. Okay, so now, how are we going to classify this risk acceptability or risk assessment or risk that we have evaluated? Now, what you need to do is to create also a matrix that also describe or also that can describe what is law, what action it takes, and medium, what action it will take. Okay, so you can also do that matrix. I have here the matrix as a sample. I put here, this is also a British standard. Okay, so I get this one from British standard, that is, I believe it's 8800. Okay, so here they scored a very high risk. This is the action, immediate action required. The activity should be ceased immediately, so there is a stoppage. If high is the score of the hazard, then this is the action. Implement short-term safety control immediately. Notify the manager so that he may decide. Okay. He may decide what action it takes. If medium, then these are the action item. If low, then this is the action item. Now, based on this particular classification, you can now prioritize. Okay, so we say that the priority is the very high. Next priority is the high, medium, and low. So we can now prioritize to solve is all the hazard that is in the number one priority. Okay, so that's how the procedure of how are we going to classify all those hazards that we identify. Now, But there are many that there are important points to consider in classifying the risk. Okay, number one is to should highlight a particularly careful assessment of individual risk exposure. Okay, the risk exposure should be performed to workers in a special group. Okay, the next classifying risk is the risk classification is the baseline of select safety action to be implemented. That is what we do in the matrix. And when the defining the time scale, the urgency of the implementation of the corrective safety measure. Okay, so that is the second one. The third one is to have a consistent base of all the risk assessment. The company should first establish the acceptability criteria. Okay, but this one has also the basis of in the law and establish standard and OHC guideline. Okay, so knowing that one, we have to formulate an acceptable standard. So this is important point to remember when classifying the risk. Now, after we have classified all the risks, we will now ready to put control on that identified risk. Now, what is risk control? Risk control is the stage where action to identify and implement safety measures to control risk are performed. Okay, but what is important here is that you cannot just suddenly put a risk control or risk measurement activity without considering the hierarchy of control. Okay? So, in the hierarchy of control, the number one that you have to consider first is the elimination. Okay. It is very important that if that particular station, process, or machine has the danger, and if possible, you can eliminate that one, then that's the best solution. Because if you eliminate that one, then you are shorting the process. At the same time, you are eliminating the risk. But if it is not possible to eliminate that one because the process or the machine is important, very important to the process, then therefore, the next more important control or the countermeasure is the substitution. Okay? If you cannot eliminate or replace, eliminate such hazard with the first step, substitution, you have to check. Okay? If you cannot replace the machine or cannot eliminate the machine, can it be substituted? If the answer is no, then the next to consider or next control measure to consider is the engineering control. What is engineering control? The safety instrumented system is one example of engineering control. Other is guarding of the machine, the elimination of that. Oftentimes, any engineering action is considered engineering control. Okay, reduce the exposure, isolate it cannot put a engineering control at one. Maybe some reduce the exposure of the operator by putting by guarding. Okay, if engineering solution by automation is not possible, you can reduce the exposure of the operator. If it still cannot, then administrative control will follow. What is administrative control? Those are the procedures the visual aids. Okay, those are administrative control. If the administrative control cannot be applied, then the last one is the PPE. Okay, why is the two administrative control in PPE is the last one to consider when you are making a controlled activity or a solution to injury or accident? It is because oftentimes the administrative control is often neglected by those person, by those operator. There are many times I have seen administrative control oftentimes, especially if that particular incident happened long time ago. So administrative control usually overlooked. And PPE is the last one. It's because PPE is a form of a hazard also. Okay? But this hazard is lower than that of the hazard that you are avoiding. Okay? Why is it hazard? Assuming that you are wielding a metal. Okay? So this is very bright. What you have to do is to cover your eyes. Then you cannot see anymore. So that is one form of hazard also. That is why, and the controlled measure, it is the last one to consider. Okay? So having knowing all of this risk assessment, what it is, all those level of protection, how are you going to assess the risk, all of it. Now, I want to show you some example of risk assessment. Okay, this is an example of risk assessment. Okay. So, if you're going to have a risk assessment, the first page of this one should be all about the machine you are considering. Okay? Assuming this one, I put a grinder, bench grinder, is because it's easy to make. Okay? So, what's in the first page? First is that this particular, as a reminder, that this particular risk assessment is in line with also the procedure. Okay, on the upper part is the overall rating of this process. The rest one is where it can be found and the time, the date of assessment. And the next one is about the specification of the machine. And also included in the first page is the, if this particular machine have a legal or law that need to be abided. So what particular law? The second layer on the right is what particular rules is applied, and also the name here is included is the team member. If the score of the hazard is very high, we will need to require the signature of the probably if the school, so this might be the president of the school or the one that is overall in charge, informing so that he can be informed that this particular process or particular machine, particular equipment is high. So you need, if very low, not required. Okay. Now, the next page is the next step. Okay, this one is the first step. The next one is the formal risk assessment. Now, in order for us to make a simple risk assessment, you can do it by asking, just like what we have done here. Can the following item become intangible, entangled? Okay, in the form of question. Okay, by this one, by questioning, you can identify the risk or the hazard associated with it. Now, if you already, by asking, you can identify, assuming this one. The question is, can the following item become entangled? If the machine is running, if you are doing you are doing something in the machine? The answer is yes. So what are those? Maybe the hair, jewelry. Okay, after you have identified the risk, then you can now apply the scoring or the assessment. This one is the likelihood on this line, then one is a consequence, then this line is the overall score. Okay, now you determine based on your matrix if this one is rare or this one is minor. It's up to the matrix that we have to, and you can score now. Okay, on the next line is the comment. You can put here if what is existing control, or what are those that is already in that particular the particular equipment. So you can have a comment here. Now on the next line is the hierarchy of control, the one I showed you before. Now here is elimination, substitution, engineering, administrative, and personal protective equipment. Now, based on this one, you assess which particular control is applicable to this hazard. Now, if you already identify the particular control applicable, then we can now put the control action or the control measure. Okay, on this particular action is referring to the engineering control. Also this one, adjustment of guard, engineering control. Clearing, emergency access for EC, then this one, administrative control. Now, this particular control measure is under administrative control. Okay, the next one is the PPE. Now, after scoring this one, having all the countermeasure in place, we can now check for the action. Action required. If this one is low, maybe no need. Okay, transfer to corrective action report, maybe no need, because there is the score overall severity is actually very low. Okay, now we continue this one by just asking and determining the risk, then scoring the risk, checking the control action needed, putting, then determining the action required or not. So we just continue this one, asking until such time we have already questioned everything. Okay, so this simple machine, we have many questions. We can assess many as possible so that we can determine the hazard systematically. Okay, this is the sample that we have made. On the third step, okay, this is now the action. And the third step is that action required by manager and supervisor or the authorized person. This is now referring to the overall score. If the overall score based on your ranking matrix is required an action or corrective action, then we can put here okay. If not, because this one is low, then if no action required because it is low, then this one will going to do. Okay, this is just a simple example of risk assessment. But even though this is a simple, this actually many of the risk assessment that I see in the factory is exactly like this. Maybe do not think too much of very complicated risk assessment. It's much better that we can make it simple and easy to understand so everybody can follow. So oftentimes that's many Japanese company is doing it. More simpler, the better. Okay, so this is the example of risk assessment. Now, In summary, in conclusion, safety instrumentation is just a part of general risk assessment management in a manufacturing plant. Okay. And for safety instrumentation to be effective, the following points are needed. Number one is you have to have a systematic hazard identification. Otherwise, if you don't know the exact risk to that particular machine, therefore, you cannot make as an effective safety instrumentation. Cannot. Maybe you can make, but it will not be effective. Okay? So the next one is hazard identity evaluation. You need to know if that particular hazard is acceptable. Okay? And it will be judged by the right person. Oftentimes, all those in the management or the corporate responsibility to judge if that particular hazard is acceptable or not. Okay, the next one is assign risk reduction function layer of protection. It is very important to ensure to have a high level of safety in our plant, in our machine, in our facility. Another one is to ensure that each safety layer is implemented to deliver the required risk reduction. Okay? Safety instrumentation system was designed and supported by the management. Otherwise, it will not be effective. The last one is to ensure that the safety measures provided are functional. Now, even though we put a safety instrumentation on that particular machine or the particular plant, it is always and always we need to check. Okay, so that's the point, the major point that we need to consider to be the safety instrumentation be effective. It cannot be, the safety instrumentation cannot be effective on its own without supporting by this particular point. Okay, before I end my presentation, I would like to state this to you, the fundamental component of safety management. Number one is to have a systematic method of identifying. That's what we do. I presented to you the safety instrumentation system, but it is equally important to me that you have to have a systematic method of identifying the risk, and it must be documented. And also, ensuring that all unacceptable risks are reduced to an acceptable level. If you identify that the risk is high, you have to prioritize this one. It cannot be eliminated. At least you put it back, reduce it to acceptable level. Number three is to having a monitoring and review in place, that monitoring implementation and performance of all the safety measure. This is very important, no? Because even you put the best system of protection or a system of safety, if you cannot monitor it, eventually somewhere in time, it will be reduced. It will be not effective anymore. So constantly, safety is a continuous commitment. Okay. Next one is the awareness of responsibilities for personnel involved in the safety administration. Okay, this is very important also. If those personnel is not aware of this responsibility, all the risk management will not going to last, will not going to continue. Later on in your production, you will see that it become more and more unsafe as the time goes by. So the key is to have to know, the personnel should know the responsibilities continuously without fail. Okay, the last one is the compliance to regulatory requirements from the national and local authorities. It is very important to be compliant to all regulatory requirements in your country. It is because it was placed to protect, not to reduce, not to control you, but to reduce and to move you away from the harm. So this is the fundamental component of safe management. Okay, so with this, I would like to say thank you very much for giving me a chance to present this presentation. And if you have question, maybe our moderator, Miss Sepi, ma'am.
Yes, thank you, Pak Chris, for the interesting lecture about how safety instrumented system applied, risk assessment, hazard identification. Well, it's so relevant, Pak Chris, with something we learned in this department. We also have a course related to the topics in the department named HSEQ, Health, Safety, Environment, and Quality. So thank you for the insight for us today. Okay, now participant, it's time to discuss. Discuss with Pak Chris. Yeah. To all participants, we are glad to please you if you have any question for Pak Chris. We will also appreciate you if you want to speak directly, ask directly to Pak Chris. It will be I appreciate. Although we have so many questions in chat box, Pak Chris. Okay, maybe participant will anybody to speak to Pak Chris? Ask directly. You can raise hand. You can click raise hand, and we will allow you to speak to Pak Chris. Yes, Dava.
How can I see?
There is Dava. We'll
Yes.
ask you. Please, Dava.
Hello, sir.
Yeah. Hello, sir.
Good afternoon.
Afternoon. So, firstly, let me introduce myself, Mister. Yeah, my name is Dava. I'm from Instrumentation Department of ITS. So I have a question that a whole of your lecture is telling us about if we increase the technologies or we make the instrument is getting automatically in operational, is decrease the chance to get the accident. So is the best conclusion of us to decrease the chance of accident is to make every machine to be automatically?
Yes, of
Yes.
course. Yes, of course, sir. Okay. Automation, actually, one of the purpose or one of the function of the automation is to reduce the risk or to make the machine safety. Now, the only problem with this one is that if we have lack of risk assessment, because the machine is not perfect, you can see that it fails also. You can see on my sample that the main cause of the problem is the failure of the component. Now, as an engineer, sir, someday you will be an engineer. As an engineer, it's your responsibility to know when, because engineer knows yes or no, nothing in between. Either it fails or not, you have to determine it. You are the responsible person to know when it's going to fail. Assuming that sensor, it is properly assessed, you can determine when it is going to fail. That is why risk assessment is very important. It's because you have to determine, you have to put a tag on that one. This one will fail this after 10 years. Actually, there is a measurement of that one. There is a system like a safety, if I remember, based on the SIS, is the safety integrated level. That's the measurement. So if the level of SIL is 1, then maybe 10 years it failed. As an engineer, So if you make a SIS system, all of your components, you can ask the manufacturer it how many times before this sensor will fail. By doing so, you can now determine, you can now assess how many times the process is do back and forth, back and forth. Now, by doing so, you can now determine in what year this one will fail, approximately. That is a job of an engineer. But you can do that one is if you properly assess. That is why I did not lecture just for the SIS. I make it sure that even though maybe some other of your classmates already know about risk assessment, but I still include the risk assessment because it is SIS is just a part. Without considering, without assessing, SIS will fail. That's definitely sure. Okay? But to answer your question, yes, automation reduce the risk. Okay?
Okay. I got it, sir.
Thank you very much.
Okay. Thank you so much, Mr. Christopher.
Thank you, sir.
Thank you, Dava, for the question. Pak Chris, we have so many questions in chat box.
Yes.
I pick one from Pak Pandu Pertamina EP Company. Pak Pandu asks about what the relation between risk assessment in SIS and risk assessment in project schedule. Maybe it is related to next question from Deva Marisa about the job hazard analysis. Maybe it's risk assessment in project. If we doing some project, we always mandatory to fill the job safety analysis or job hazard analysis. Is it different? What the different risk analysis on SIS and project, Pak Chris?
Okay. The difference between the two is only about the area of consideration, but the process, the system of determining is just the same. So the only difference is that what criteria or what process are you going to include in the consideration? But the system is just the same. The method is just the same. Okay? So I hope you understand this one. By the way, regarding to the project implementation, I'm not, actually, I did not conduct one of that one. I don't have much experience about project risk on the scheduling. But on the machine, actually, I'm more familiar with that one. But based on the process, based on risk assessment that I see within the company, it's always the same. It's just a matter of the criteria or the process or the area that is included on the system is the only difference. Okay?
Okay. Okay, thank you. So it's just the same, but the method was the same. Maybe it's the name of the document will be make it looks different. There is so job hazard analysis, job safety assessments, like, but all the method is the same, right?
Yes.
Okay.
Actually, the most critical on that particular assessment is the member.
Okay.
So you have to get a member that is much familiar with the area of consideration where you are going to conduct a risk assessment. So very critical to find the member that it will include. Who's the person that is very good in assessing on that particular area. Okay?
Okay. Thank you. Thank you, Miss Pa Chris. So we have a long question here from Rafli Zakarullah. Yeah. I'll call Rafli Zakarullah. Better you speak directly because the question is so long. Yeah, Rafli. Hello, Rafli. Do you hear me?
Hello.
Yes, Rafli.
Hello, sir.
Your question is so interesting and so long. Please ask directly to Pak Chris, short and straight to the point, please, Rafli.
Can you help me, Mrs.?
Oh, okay.
Because I cannot speak English very well.
Okay, it's okay. Don't worry. It is. You have to try to speak, but it's okay if you want me to read your question roughly. Okay.
Maybe I speak Indonesia. You can help me to translate. Or
Okay, it's okay. Hagai will help you translate. Yes. Okay, Rafli, just say Rafli.
baik, saya pakai bahasa. Oke. Jadi pertanyaannya saya lihat di data di slide kelima itu dilihat datanya itu antara 2013 dan 2015 di operator sistem. Nah, itu di operator sistem itu tingkat kecelakaannya itu sangat meningkat dari 3.000 menjadi 5.000. Bahkan di tahun 2015 pun itu meningkat lagi, lebih banyak daripada orang yang tidak punya pengalaman, yang tidak punya keahlian. Angka kecelakaan orang operator itu lebih tinggi daripada angka kecelakaan orang yang unskilled seperti itu. Nah, mengapa hal itu bisa terjadi? Harusnya kan tambah maju itu Ibu. Dari 2013, 14, 15 harusnya kan to be better. Nah, ini malah nambah angka kecelakaannya. Dan ini apa yang menyebabkan hal ini bisa terjadi dan apa tindakan yang diambil oleh orang-orang terkait untuk mengurangi kejadian ini di masa mendatang seperti itu, Ibu.
Okay, thank you, Rafli. So the question from Rafli is why the number of accident which happen in operator who operate the machine is higher than unskilled worker, and why and how to fix it in the future like that, Pak Chris.
Okay. You are very observant. Sir, you are very observant. Now, that is why the reason why the construction or the unskilled or the manual labor go high is that because of the program of the government. Okay, there are many programs the government have been approved. There are many laws. So the work of the construction is not complicated as with the manufacturing. Okay, because of this automation, there are many processes that become complicated and requires special attention. Okay, that is why when you fail, especially in engineering, when you fail to monitor or to in an engineering and maintenance, when you fail to have a program of maintenance, then on that particular parameter will fail, and this one will result in accident. There are many things to control in the manufacturing than in construction. This is the difference. That's why it's very critical on the manufacturing. That is why training is one of the best solutions. Before we put all the operator of the machine, it should be trained and should be familiar with the machine that they are operating. That is the more important thing. And also equally important is that that person should be aware of the risk associated with that machine. It is important they are familiar with that one. Failing to do that one is the reason why there are many accidents in the manufacturing, because it is very different to control it, even though it is automated. Automation is also have the chance to fail. That is why we have redundancy of safety measures. We do that one to reduce the risk. We do that one, but still, mainly risk is in the manufacturing comparing to other industry. Okay, I hope that I answered your question.
Okay, thank you, Pak Chris. Let me translate for Rafli. Jadi Rafli intinya ya karena ada banyak teknologi, banyak mesin-mesin otomasi, maka akan banyak parameter-parameter yang harus diperhatikan gitu. Maka solusinya itu yaitu ada training dulu kepada operator-operator tuh yang harus dia aware terhadap gimana cara kerja mesinnya dan lain sebagainya. Itu Rafli ya, semoga menjawab. Okay, thank you. Rafli, is there any other question?
No.
Is enough? Okay.
Enough.
Okay, thank you, Rafli. Okay, I will pick one more question from, I'm sorry, from Divanata Faris. What layer of protection can be used to detect and respond to abnormal reaction or process condition, and how to from Fikri, and how to determine the safety integrity level?
Okay.
It's Pak Chris, please.
Okay.
Yeah.
For the layer of protection, if you want to determine only, it's on the second layer. Okay. So the monitoring of those parameters of the second layer, because if the parameter actually is go outside the normal, it will alarm you. So the monitoring of the determination of that one is at the second layer. Okay. Maybe she are asking about, or he is asking about, because maybe he's thinking about the safety level, I mean the SIS. SIS is a function, a specific function. It is being applied, only applied for those very dangerous situations. Okay, but if the protection is to you're asking is about determination, knowing the parameter is going out or within, then the second layer. Okay, now how do we determine the SIL? First, if you are going to make SIS or the system, there are many components. All you need to know is to ask the manufacturer. Actually, when you buy a sensor, there is already the so-called probability of demand. Now, in that particular specs, you can now determine how many times you can use that machine. Okay, assuming 1 million times. Okay, 1 million times you can use that machine in the process. Now, you ask your question, how many times in your manufacturing using that particular sensor? Maybe 100 times every year. So 1 million divided by 100,000 become 10 years. So that's easy. That's arithmetic calculation. So if you have many components, just determine which one is the lowest. You can be safe on that one. Anyway, there is no exact calculation for that one. It's only approximation. Okay, I hope you understand that one now.
Okay. Okay, thank you for the answer, Pak Chris. Okay, because the time limit, maybe I will pick one more, the last question in the chat box, Pak Chris, from Pak Pandu, Pertamina EP Company. He said that he need comprehensive explanation about alarm system in upstream oil and gas plant that applied for gas H2S, hydrogen sulfide, yeah, hydrogen sulfide vapor cloud. It's Pak Chris about how the comprehensive explanation in this plan.
Okay. Regarding to that particular company, ma'am, actually I will admit to you that that company actually is more very critical than that. What I don't want to answer that question. It's because I don't have experience about chemical plant. Okay.
Okay.
the level of assessment there are different. Actually, more company, they are using a system of, they call it HACCP, a different risk assessment, but they are focused on operational and risk assessment as a whole. So this is a very big consideration. Okay, this is much different from the hierarchy. So that's why I don't want to give a wrong answer for that particular question. So
Okay.
I'm sorry if I
Yes,
have a shortcoming.
it's okay. It's okay, Pak Kris. So jadi Pak Pandu, Pak Kris, dari jawaban Pak Kris, gimana caranya untuk bisa teknologi yang penting itu untuk mendetek H2S, bahaya di H2S. Thank you Pak Pandu masukannya. Okay. I know a really interesting topic, but I apologize because we have time limit, Pak Kris. So I hope we can do a further discussion in other occasion, Pak Kris, and maybe we can doing some positive collaboration in the future. So okay, that's all. Before I finish this session, Pak Kris, would you mind to give a closing statement for our student and our participant today?
Okay, so first of all, I would like to say thank you very much for giving me a chance to talk to everyone, because this is the first time I've been a speaker for a international. Okay, so I am always speaking only to a company, to in between companies. Okay, this is very good experience for me. And actually, I am very happy that there are many students ask their question, because it shows a participation, a interest in the subject. So I would like to say thank you very much to everyone, especially the in charge of this particular program, International Speaking. I forgot actually the entire title, but I would like to say thank you very much, sir, everyone, Ma'am Sepi.
Yeah.
So thank you very much for giving me a chance to attend this particular webinar. Thank you.
Thank you. Thank you, Pak Kris. For our student who wants to discuss further with you, would you mind to allow our student to discuss or contact you?
Yes,
Maybe?
at the back of my presentation, ma'am, I have this email.
Oh, okay.
Okay, so if you are interested, because oftentimes during the speaking, I have some limited, but if you give me a chance to give me all your question, definitely I will give you an answer. With my limited capacity, I will give you the best that I can to answer your question. Okay, so you can
Thank
email me on
you.
that one.
Thank you. Thank you for the opportunity and allow you to discuss you, contact you through email. Thank you. We will so happy about this. We appreciate about this. Thank you. Okay. Thank you for everyone, for participant, for student, for joining us today. I hope in the future we can doing some positive collaboration with Pak Kris and students. Thank you, everyone. I'm Sefi as moderator. I apologize if there is a mistakes while moderating this session. Thank you, and I finish it. I end it with good afternoon. Assalamualaikum warahmatullahi wabarakatuh. And back to you, Hagai.
Waalaikumsalam, Mrs. Sefi. Well, thank you, Mr. Christopher, for the knowledge sharing, for the lecture, for the material you have shared with us, for the question and answer session, and for the discussion regarding the plan and equipment risk assessment. And it was a fruitful and tangible knowledge, and I believe all the knowledge you have shared will be useful for every single of us here. Also, thank you, Mrs. Sefi, who has moderated the presentation to question and answer session. Well, for this session, Mr. Christopher, we have an award of appreciation for you. So please remain stay in the Zoom meeting, and maybe the operator could share the screen of the appreciation, please. Yeah. So, Mr. Christopher, this is a little appreciation from us for your willingness to share your knowledge to us. Mrs. Evi?
Thank you, Pak Chris, for your willingness today, because we are virtually, we only have this for you. I'm so sorry. I hope we can meet in Indonesia next time. Pak Chris, thank you.
Thank you, ma'am. Appreciated. Thank you very much.
Okay.
Are we going to have a documentation for this session, Mrs. Evi?
Yes, okay.
The operator, could you please? Well, all right. Okay, that's all for the appreciation session. Mr. Christopher, we are looking forward for the further discussion for another opportunity in the future. Open your camera. Okay. There are still a lot of you who haven't opened your camera, so please open your camera, guys. Okay. Here for the operator, maybe you could count down for the documentation.
Okay, I will take this session, the documentation. And here there are 7 slides in here. I will be first in slide 1. In slide 1, I will start in here. 1, 2, 3. Okay, next slide. In slide 2. 1, 2, 3. Okay, in slide 3. 1, 2, 3. Okay, in slide 4. 1, 2, 3. In slide 5. 1, 2, 3. In slide 6. 1, 2, 3. And the last slide. 1, 2, 3. Okay, thank you, guys.
Okay, thank you, Riela. And that's all for the documentation session. Now, before I close this event, I would like to give a little quotes as how Evel Knievel once stated that risk is good, not properly managing your risk is a dangerous leap. My name is Hagaya Mima, the Master of Ceremony. Thank you for joining this event since the start to the end of this event. Also, thank you for everyone participating in arranging this event. With it all being said, then this event is already done. Hope you guys have a great day. Thank you and goodbye. The participant is already allowed to leave this room. Thank you. And don't forget to fill the presence link and fill the feedback link. Thank you, guys. Goodbye.
Thank you, Pak Christopher.
Thank you, ma'am.
This can't be love because I feel so well. No sobs, no sorrows, no sighs. This can't be love I get no dizzy spell. My head is not in the skies. My heart does not stand still. Just hear it beat. This is too sweet to be love. This can't be love because I feel so well, but still I love to look in